Hello, this is Akshay Agrawal with another video here, and this time around I am taking you can say a doubt from one of the viewers named as Keshav Patel. He has asked this very question which I have put over there, that can we use half or two instead of 2mg. Let me just expand this very question for your convenience here. So mg reacting with oxygen to give MgO here. So there is a way to balance a chemical equation, that is it is 2 and it is 2. Why? Because oxygen having two atoms here oxygen is having only one, so we have multiplied this whole MgO by 2. So this means that here it is being a multiplier, oxygen atoms has become 2, it is 2, and Mg is having 1, so this way 2 is gonna be a multiplier to this 1 as well. So here Mg was 1, it is also multiplied by 2. So 2Mg plus O2, 2MgO. Or no, this is his question where he has asked, that is Mg plus half O2 to give MgO. Here it is, this very part here, Mg plus half O2 means here Mg1, Mg1, oxygen 1, oxygen 2. So 2 को अगर हम half से multiply करें, 2 if it is multiplied by half, then what's gonna happen? 2 ones are 2, 2 ones are 2, and it stands equal to 1. So here 1 by 2, 1 upon 2. So this is what he has asked, that can we use half O2, here it is, can we use half O2 or instead of 2mg, here it is 2mg. Means simply speaking, he has asked, that is which one is the right kind of a balancing here, is it right or is it right or both are right, you can say there. So let me tell you very clearly here, we can use the fractional coefficient. There is no problem whatsoever in using the fractional coefficient. These are called fractional coefficients and these are called whole number coefficients. So we can use the fractional coefficient, and if you are learning the fundamentals of balancing of a chemical equation, then we should go for this, because of the reason that it's essential to get rid of these fractions there. So if you are going to multiply this whole chemical equation by 2, इस पूरी केमिकल इक्वेशन को 2 से अगर आप मल्टीप्लाई कर देते हो, here it is, this many 2, so 2 से जब आप मल्टीप्लाई करोगे it will become 2mg. 2 से जब आप मल्टीप्लाई करोगे इसको, so 2 and 2 gonna cancel here, this 2 and this 2 is gonna cancel, and this very 2 is gonna multiply over here and it will come 2mgO, 2mgO. So there is this kind of a ultimate equation you are gonna get. Now I am coming back to the question here, that is it right to use half O2 instead of 2mg? Let me clarify here, that is this kind of the fractional coefficients can be used, and most importantly in solving many problems the fractional coefficients are put into use there. For example, as we are going to deal with thermodynamics, here we are going to find out the standard heat of formation of a compound, and in that case we need the fractional coefficients there. We need those kind of fractional coefficients, because for 1 mole of formation we are going to calculate the standard heat of formation of that very compound. 1 mole, here you are seeing 2 mole of MgO are forming, here you are seeing 1 mole of MgO is forming. So there is a difference here, 2 MgO, here 1 MgO. So if you are coming across thermodynamic section there and dealing with the numerical problems there, or finding out the standard heat of formation in a given chemical reaction for a given compound there, then you are required to have that kind of a situation over there, this kind of a situation. So that kind of a chemical equation is gonna be accepted in dealing with thermodynamical processes there. So this is not a wrong way to balance a chemical equation. We can deal with or by using the fractional coefficients here. At the end of the day, the number of atoms, as the definition of chemical equation clearly states, that the number of atoms of both the elements on the right hand side must become equal to the number of atoms of those elements on the product side, and if that is happening, then that chemical equation is going to be known as a balanced chemical equation. So this is also a right kind of a chemical equation, but at the lower level. At the lower level, while you are just understanding that how a balance a given chemical equation, then you can get rid of these fraction there. Means आप इससे छुटकारा पा सकते हो, फ्रैक्शन को ना यूज करें, स्टेटा में ऐसे लिखें, then it's gonna be okay. But इसका मतलब ये नहीं है कि अगर आप फ्रैक्शनल कोएफिशिएंट आप यूज करते हो तो ये गलत है. No way, it's not a wrong, it's a right kind of a strategy, and its importance appears when you are gonna step on the thermodynamics there in the higher classes. Then you will come to know that our teacher was quite right in telling us that both the bases are right there in order to balance a given chemical equation. And most importantly, in thermodynamical process, we do prefer the fractional coefficients here. So that's what was the question, and let me just summarize it here. Both the bases are right. You can deal with the fractional coefficients A and the B if you are learning the chemistry section in the beginning there, while you are 8th class, 9th class, just try to understand the process to balance a chemical equation. Then you can get rid of the fractional coefficient, no problem at all. But if you are dealing with the thermodynamical processes, as I have mentioned one of the examples there, to find out the standard heat of formation for a compound, then you can prefer, or you will rather prefer the fractional coefficient. So that very question pertaining to this very half O2 is quite over here. That is, yes, it's right, this can be used as well as this can be used, but at the lower level, while you are understanding the fundamental, you can get rid of the the fractional coefficients there. But ultimately, in final analysis, the use of fractional coefficient is not a, you can say, a prohibited way. It is used very clearly in the thermodynamical process, in the higher, you can say, that is chemistry section there, where we are dealing such kind of processes there. So this is quite right, this is also quite right. Any of the way to balance this very chemical equation can be put into use here. I do hope that the doubt must have cleared in your mind, and if you are any kind of a doubt regarding to this very section related to balancing of a chemical equation, you can shoot it at me in our comment section there. That's it here.